Good day everyone, welcome back to the continuation of our discussion on the topic, the application of integration. Today we'll be addressing area under two curves. Now for area bounded by two curves, let's say we are given two curves f of s and g of s as shown in the diagram, and we are asked to look for the area bounded by the curves as indicated by the shaded region. Now, for us to be able to do this, let's try and separate the two curves and find the area under each curve individually. Now, if we are working with just f of s, the area under our curve will be equals to the integral of f of s to our limit being b and a. And also, if we are working with just g of s, the area under our curve will be the integral of g of s with our limit being b and a. As we can see, the area bounded by the two curves is the difference between our integral of f of s and our integral of g of s. That is, when we subtract the integral of g of s from the integral of f of s, we are going to get the area bounded by the two curves. So therefore, the area bounded by the two curves, which is the region highlighted, will be equals to the integral of f of s with our limit being b and a minus the integral of g of s with our limit being b and a, which can be simplified further to be equals to the integral of, in bracket, f of s minus g of s with our limit being b and a. So when we are evaluating area bounded by two curves, is usually the integral of one of the function minus the integral of the other function, taking our limit for both points where the two function intercept, or the intersection of two function. Our very first question is from November 2000, and it states that that's AI, sketch on the same axis the curve y equals to 5s minus s square and the line y equals to s plus 3. Find the coordinate of their point of intersection, and b, find the area of the segment cut off from the curve by the line. Now our first part of the question is to sketch our curve, and in sketching our curve we are going to be needing our turning point, our s-intercept and our y-intercept. So our first call of duty is to look for our turning point. Now writing our equation y equals to 5s minus s square and differentiating, the y over the s will be equal to 5 minus 2s. At turning point, the y over the s is equal to 0. So substituting the y over the s to be equal to 0, it becomes 5 minus 2s is equals to 0. And simplifying further, it becomes 5 is equals to 2s. And dividing both sides by 2, s will be equals to 2.5. Now we're going to be looking for the value of y at turning point, and to do that we are going to be substituting s equals to 2.5 in our original equation, which makes it y is equals to 5 in bracket 2.5 minus 2.5 in bracket squared, opening our bracket to be equals to 12.5 minus 6.5, which is equals to 6.25. Now we've gotten the value of our turning point and the value of y and s at our turning point. Now the next point of action is to determine if our function is maximum or if our function is minimum, to know the direction of our curve. And we know that at the square root over the s square, when the square root over the s square is greater than 0, it is minimum point, and if it's lesser than 0, it is maximum point. So differentiating our function to get the square root over the s square, it will be equals to minus 2, which is lesser than 0, and hence is a maximum point. Next, we are going to be looking for our s-intercept and our y-intercept. Now intercept on the s-axis, y will be equal to 0, so substituting y equals to 0 in our equation, 5s minus s square will be equals to 0, and factorizing s into 5 minus s will be equals to 0. So therefore s will be equals to 0, or 5 minus s will be equals to 0. This makes s to be equals to 0, or s is equals to 5. The next, for our y-intercept, s will be equals to 0, and substituting s equals to 0 in our equation, it becomes y is equals to 5 in bracket 0 minus 0 square, which will be equals to 0. Now we've gotten our coordinates for our turning point, our y-intercept and our x-intercept, and we can easily sketch our curve. Now for our straight line, we'll be needing just 2 points. Basically, we'll be needing our y-intercept and any other point on the curve. Now when s equals to 0, y will be equals to 0 plus 3, which is y will be equals to 3, and when s equals to 1, y will be equals to 1 plus 3, that is y is equals to 4. Now we'll be able to use these 2 points to plot our straight line, and when we do that, we get the sketch as shown on the screen. Now the next part of our question is to find the coordinates of their points of intersection. To get the coordinates of their point of intersection, we are just simply going to be equating both function or both equation together. That is 5s minus s squared will be equals to s plus 3, and simplifying further by bringing our s plus 3 to the other side, it becomes s squared minus 4s plus 3 will be equals to 0. At this point, we are going to be factorizing using factor method. Now looking for two numbers, usually we multiply them will give us 3, and when we add them will give us minus 4. The number is going to be minus 3 and minus 1. So splitting minus 4s into minus 3s and minus s, it becomes s squared minus 3s minus s plus 3 is equals to 0. And factorizing further, it becomes s minus 3 in bracket, s minus 1 in bracket will be equals to 0. Thus s minus 3 will be equals to 0, and or s minus 1 will be equals to 0, which makes s to be equals to 3 on 1. Now for the final part of our question, which is the area of the segment, we know that the area of a segment will be equals to the integral of f of s minus g of s in bracket ds, and in this case our f of s is 5s minus s squared and our g of s is s plus 3. So therefore the area of the segment will be equals to the integral of in bracket 5s minus s squared in bracket minus s plus 3 in bracket ds, our upper limit being 3 and our lower limit being 1. Simplifying the bracket to be equals to the integral of 4s minus s squared minus 3 in bracket ds, and integrating to be equals to 4s squared divided by 2 minus s cubed divided by 3 minus 3s with our upper limit being 3 and 1. Now our next step is to substitute for our limits, that's our upper and lower limit, and subtracting. Doing so, it will be equals to in bracket 4 in bracket 3 squared divided by 2 minus 3 cubed divided by 3 minus 3 in bracket 3 minus in bracket 4 over 2 minus 1 over 3 minus 3. Now we're going to be simplifying both brackets, and what we do to it becomes 18 minus 9 in bracket, which is basically 0, minus in bracket minus 1 over 1 over 3. Our final answer will be equals to 1 over 1 over 3 square units. Our next question is from UME 2001, and it states that find the area bounded by the curve y is equals to 4 minus s squared and y is equals to 2s plus 1. Now the very first thing we are going to do is sketch our curve, and we are going to be needing our turning points and s and y intercepts if any. Now writing down our equation, y is equals to 4 minus s squared, and differentiating, the y over the s will be equals to minus 2. At turning point, the y over the s is equals to 0, so substituting 0 for the y over the s, minus 2s will be equals to 0, and dividing both sides by minus 2, s will be equals to 0. Now the value of our turning point is gotten by substituting s equals to 0 in our original equation. Doing that, it becomes y is equals to 4 minus 0, which is equals to 4. Next, we are going to be looking for our s-intercept and our y-intercept. Now for our s-intercept, y will be equals to 0, so substituting y equals to 0, it becomes 0 is equals to 4 minus s squared, and simplifying, s squared will be equals to 4, and finding the square root of both sides, s will be equals to plus 2 and minus 2. For our y-intercept, there is really no need for looking for our y-intercept, because we already know that at the point where s equals to 0, y is equals to 4, and that is our y-intercept. Now for our straight line, we are going to be looking for our y-intercept and our s-intercept of the straight line. So when s equals to 0, that's our y-intercept, y will be equals to 2 in bracket 0 plus 1, and y will be equals to 1. And for our s-intercept, that is when y is equals to 0, 0 will be equals to 2s plus 1. Breaking down, 2s will be equals to minus 1, and dividing both sides by 2, s will be equals to minus 0.5. Now using this coordinate to sketch our curve, we are going to be having a sketch as shown on the screen. Now here we don't know our limit, so to get our limit for our integration, we are going to be integrating both equations together so as to get the point where they both meet, basically, which is also our unit. So doing so, 4 minus s squared will be equals to 2s plus 1, and rearranging, it becomes 4 minus s squared minus 2s minus 1 is equals to 0. Rearranging further, it becomes 3 minus 2s minus s squared is equals to 0. Now we're going to be multiplying through by minus to make the equation a standard form of quadratic equation, and multiplying through by minus, it becomes s squared plus 2s minus 3 is equals to 0. Now we are going to be factorizing s squared plus 2s minus 3 equals to 0 using factor method. Doing so, we'll be looking for two numbers in which when we multiply them, it's going to give us minus 3, and when we add them together, it's going to give us 2. Now the number are plus 3 and minus 1. So splitting 2s equal plus 3s and minus s, it becomes s squared plus 3s minus s minus 3 is equals to 0. Factorizing, it becomes s into s plus 3 minus 1 into s plus 3 is equals to 0. And since our brackets are the same, it becomes s minus 1 in bracket s plus 3 is equals to 0. So therefore, s minus 1 will be equals to 0, and s plus 3 will be equals to 0. Simplifying, that makes s to be equals to 1 or minus 3. So this is going to be our limit for our integration. Now to get our area for our bounded region, it is going to be the integral of f of s minus g of s in brackets, with our limit being 1 and minus 3. So therefore it will be equals to the integral of, in bracket, 4 minus s squared in brackets minus 2 plus 1 in brackets, with our upper limit being 1 and our lower limit being minus 3. Simplifying the bracket, it will be equals to the integral of 4 minus s squared minus 2s minus 1 in brackets, with our upper limit being 1 and our lower limit being minus 3, which when simplified further will be equals to the integral of 3 minus 2s minus s squared in brackets dx, our limit being 1 and minus 3. Integrating, it will be equals to 3s minus 2s squared divided by 2 minus s cubed divided by 3, with our limit being 1 and minus 3. Simplifying further, the 2 will cancel out, so we are left with 3s minus s squared minus s cubed divided by 3, our limit being 1 and minus 3. At this point, we are going to be substituting our upper and lower limit, and when we do that, it will be equals to, in bracket, 3 into 1 minus 1 squared minus 1 cubed divided by 3 minus, in bracket, 3 into minus 3 minus minus 3 in bracket square minus minus 3 in bracket cube divided by 3. And simplifying further, it will be equals to, that's simplifying our brackets, it will be equals to, in bracket, 3 minus 1 minus 1 over 3 minus, in bracket, minus 9 minus 9 minus, in bracket, minus 27 divided by 3. When we simplify both brackets, it will be equals to 2 minus 1 over 3 in bracket minus, in bracket, minus 9, which will be equals to 2 minus 1 over 3 plus 9, and simplifying the fraction to be equals to 6 minus 1 plus 27 divided by 3, which is equals to 32 over 3, and it's also equals to tail number 2 over 3 square units, and the correct option is C. Now our next question is from PC in 2000. It states that find the area bounded by the curve y is equals to s squared and the straight line y is equals to 3s. Now in this case, we have a very unusual problem, because once we try and sketch our curve, we'll realize that most of our points are at the origin and we will not have sufficient points to be able to sketch the curve. So in this case, we are going to be assuming different value for s punching it into our equation and getting the corresponding value for y. So we'll be doing this for y equals to s squared for the range of minus 3 and 3. And when we do that, when s equals to minus 3, y will be equals to 9. When s equals to minus 2, will be equals to 4. All down to when s is equals to 3, y will be equals to 9. But for our straight line, we just need 2 points. So we are doing when s equals to minus 3, y will be equals to minus 9. And when s is equals to 0, y will be equals to 0. So we are going to be using these points to sketch our curve. Now the next part of our question, or what we are going to be doing next, is to get the coordinates or our limits of our integration. So to do that, we are going to be equating both equations. So therefore s squared will be equals to 3s, and rearranging, s squared minus 3s will be equals to 0. Factorizing, because s into s minus 3 is equals to 0, either s will be equals to 0 or s minus 3 will be equals to 0. So therefore s will be equals to 0 or 3. Now from the sketch, we are now going to be looking for our area, and we know that the area of our bounded region will be equals to the integral of f of s minus g of s ds. So the area of our bounded region will be equals to the integral of 3s minus s squared in bracket ds, our upper limit being 3 and our lower limit being 0. Integrating, it will be equals to 3s squared divided by 2 minus s cubed divided by 3, with our upper limit being 3 and our lower limit being 0. So substituting in both cases, it will be equals to 27 divided by 2 minus 27 divided by 3. And when we simplify the fraction, it will be equals to 18 minus 54 divided by 6, which will be equals to 27 divided by 6, or equals to 4.5. And our correct answer is B. Our last question is from WAEC 2002, and it states that a fixed point A with coordinates m and n lies on the curve y is equals to s squared plus 1, and the line y is equals to s plus 7. A, find Roman figure I the two possible coordinates of A. Roman figure II, the distance between the two locations of A. B, sketch the curve and draw the line. C, find the area of the finite region enclosed by the line and the curve. Now to get our point of intersection, we are going to be equating both values of y, that is s squared plus 1 will be equals to s plus 7, and collecting like terms and simplifying, it becomes s squared minus s minus 6 is equals to 0. Now factorizing this using factor method, we are going to be looking for two numbers in which when we multiply them, it's going to give us minus 6, and when we add them together, it's going to give us minus 1. Now the two numbers are plus 2 and minus 3. So splitting minus s into plus 2s and minus 3s, it becomes s squared plus 2s minus 3s minus 6 is equals to 0. Now factorizing, it becomes s into s plus 2 minus 3 into s plus 2 is equals to 0, and since our brackets are the same, it becomes s plus 2 in bracket s minus 3 in bracket is equals to 0. So therefore s plus 2 will be equals to 0, which makes s minus 2, or s minus 3 will be equals to 0, which makes s 3. So our value for s is equals to minus 2 or 3. Having gotten the value for the coordinate of s, we are going to be looking for the coordinate of y. Now when s equals to minus 2, y will be equals to minus 2 in bracket square minus in bracket minus 2 minus 6. This all simplifies to be equals to 0. And also when s equals to 3, y will be equals to 3 in bracket square minus 3 minus 6, which also simplifies to 0. Thus the coordinates of A are minus 2 and 0 and 3 and 0. Now the next part of our question is to find the distance between the 2 points of A. And the formula for finding the distance between 2 points is the square root of s2 minus s1 in bracket square plus y2 minus y1 in bracket square, and substituting this will be equals to the square root of in bracket 3 minus minus 2 all squared plus 0 minus 0 all squared. This will be equals to the square root of 25, which is equals to 5. Now for the B part of our question, we are asked to sketch the curve and draw the line. Now it will be very difficult to sketch our curve by calculation because our points will all give us zero. That is, most of our value will be giving us zero reaching, and we can not sketch with that insufficient coordinates. Now what we are going to be doing is to substitute for different value of s and find the corresponding value of y and use that to sketch our curve. Now doing that for the range of -3 and 3, the values are on the screen, and we are also going to be doing that for our straight line, but we'll be using just 2 points when s equals to 0 and when s equals to 3, and the value is also shown on the screen. Now having gotten the different coordinates for our curve and our straight line, we are going to be sketching using this value. Using our point and sketching, we are going to get the value as shown on the screen, and from the sketch we can see that our uppermost function is a straight line. So for the final part of our question, that's the area enclosed, it will be equals to the integral of g of s minus f of s ds, taking our limit to be 3 and -2, which will be equals to the integral of s plus 7 in brackets minus s squared plus 1 in brackets, all in bracket ds, with our upper limit being 3 and -2. And when we simplify our bracket, it will be equals to the integral of s minus s squared plus 6 in bracket the s, our upper limit being 3 and -2. Differentiating to be equals to s squared over 2 minus s cubed over 3 plus 6s, our upper limit being 3 and our lower limit -2. Now substituting our limits, it will be equals to, in bracket, 3 squared over 2 minus 3 cubed over 3 plus 6 in bracket 3 minus, in bracket, -2 in bracket squared divided by 2 minus -2 in bracket is to the power of 3 divided by 3 plus 6 into -2. Simplifying both brackets, it will be equals to 9 over 2 minus 9 plus 18 in bracket minus, in bracket, 2 plus 8 over 3 minus 12. And simplifying both brackets further, it will be equals to 27 over 2 plus 22 over 3. And when we solve this fraction, it will be equals to 125 over 6, which is also equals to 20.83 square units. Here are some exercises for you to try your answer on at home. The answers to this question are found in our Hidden Facts Further Mathematics textbook. You can easily get the hard copy, or if you are interested in the soft copy, you can get it at the website on the bottom of the screen.